In the previous lecture, we designed the token class. Today, we're going to begin building the Lexer, which is responsible for breaking our source code into tokens. Let's start with a simple example. This example source code is a few lines of code that we want to tokenize. Let's begin with this line. This line creates a new Lexer object and passes our source code to it. During the object creation, the init function of the Lexer class is automatically invoked. The init function is like a constructor. It sets up the initial state of the object. In our case, it takes the source code, splits it into lines, and prepares the Lexer to start working with it. When the Lexer is initialized, the first thing it does is split the source code into individual lines using the splitlines function. This splits the source code into a list of lines, allowing us to handle one line at a time. If we add this line below it, we get the following output. This shows what source code contains after the split. Let's take a look at how the tokenize method currently works. It loops through each line of the source code and prints it out. But notice that the first element in the list is an empty string, because there's an empty line at the beginning of the source code. To fix this, we can modify the code to skip over empty lines. We can check if the line is empty using the strip method. If the line is empty, we simply skip it. With this change, the empty line is skipped, and we're ready to process only meaningful lines of code. So far, we've successfully iterated through each line of the source code. However, since our goal is to extract finer details like variables, operators, and numbers, we need to go a step further and iterate over each line character by character. Inside the tokenize method, we now introduce a while loop that reads each character in the line. We start by setting position to 0, meaning we begin at the very first character of the line. The len function is then used to find the total number of characters in the line. The while loop continues to run as long as position is less than the length of the line. Inside each loop, we do this to extract the current character with the corresponding character position. Here's the output we get from the current code. As you can see, we are printing each character in the source code, including the whitespace characters. But these empty characters don't give us any meaningful information, so we can skip them. So let's modify the code to skip any spaces. We can use the isSpace method, which checks if a character is a whitespace. If it is, we move on to the next character. Now that we're skipping the whitespace characters, here's the updated output. As you can see, the empty spaces have been removed, leaving us only with the meaningful characters.